Compare large CSV files. We often encounter the need to compare data, and here are two large CSV files, m.csv and n.csv, which all use A, B, and C as the primary keys, and we want to compare them to find the following data. Find records with the same primary key value, but different values in other fields. This calculates the intersection of M and N, while also removing completely identical records. Find the unique records of the primary key value in M, which is the difference set between M and N. Find the unique records of the primary key value in N, which is the difference set between N and M. When comparing two datasets, it is necessary to align them by primary key, which makes it easier to sort them first. However, retrieving and sorting large files can be cumbersome. SPL has specialized big data sorting and join functions, making it easy to calculate intersection and difference sets. A1 loads m.csv using the t function. Use the @c option to indicate that cursor reading will be used. Use the sortx function to sort by the primary keys A, B, and C. Sortx is specifically designed for big data sorting and automatically processes the buffer, returning an ordered cursor. Similarly, A2 sorts n.csv. A3 uses the joinx function to associate these two ordered cursors, and joinx will also fetch data in batches. Separate multiple tables to be associated with semicolons in the parameters, and separate multiple primary keys with colons. A3 defines the join operation on the cursor, but the calculation does not start at this time. It is not until A6 saves the calculation result to a file that the predefined series of calculations will be carried out. To observe the join results, we can use the fetch function to get 3 records and view them. The field values of each result is the 2 records associated with M and N. A4 uses the select function to select records with difference in other fields based on the A3 join results. When it is not convenient to use column names, a column value can be obtained using the # plus column number method. Here, in the filtering expression, #1 is the record of M, #1.4 is the FA of M, and #1.5 is the FB of M. Similarly, #2 represents the record of N. A5 uses the new function to organize the filtered results from A4 into the final data structure. M's FA and FB are renamed as FA1 and FB1, while N's FA and FB are renamed as FA2 and FB2. At this point, if you fetch the result in A5, you can see that the data from the two files has been concatenated together. In A6, use the t function to save the A5 result as intersection.csv. The task of calculating the difference set is relatively simple. For the cursor groups of M and N in A3, use the merge function to calculate its difference set. The option @d represents the difference set. In addition, there are more options such as @u to calculate union and @i to calculate intersection. The parameters specify calculation by comparing the primary key fields A, B, and C. M in front represents calculating the difference set between M and N. To calculate the difference set between N and M, simply swap the order of the cursors in A3 so that N comes first in A2. Finally, A4 stores the difference set result in the difference.csv file. SPL has more examples of this kind. Welcome to like and follow.